A vertical Newton's second law problem. On purpose, I've made this one a little bit weird in that it's an elevator accelerating down. Well, not that it's weird, but I solve it maybe differently than what you did last year. Always going to start one of these Newton's second law questions with a free body diagram. In this case, a person standing in an elevator has the normal acting upward on them and gravity acting downward. Since they're accelerating down, I know that gravity is winning that tug of war, so I'm drawing the gravity force as being a little bit longer. Also, when I set up F net equals ma, since it's accelerating down, I'm going to make down positive. And then by default, the normal force is going to be a negative force. If you don't do it that way, you'll still agree with the right answer as long as you put in the 2 into your equation properly. I like always, when I can, making the direction of acceleration positive. I just find it works better. I don't get into issues with negatives and questioning whether I should put in a negative or not. When I expand this one out, I'm eventually going to do mg. I'm going to put in 9.8 for g. Sometimes people ask me if it should be 9.8 or negative 9.8. I've already dealt with my direction, so I don't put a negative with the 9.8 because that would be adding to the direction, but I've already dealt with it. So literally just going to plug in the value. When we get down to algebra, if I flip things around, Fn all by itself is the mg minus the ma. I'm working without a calculator, so I would common factor out the m to get that. The mass I made up was 50, 9.8, and the acceleration I made up was 2. I did use a calculator. I did use a calculator to figure this out, but we get a nice number, 390 newtons. If you did it differently, setting up your F net equals ma, as long as you dealt with the signs properly, you should agree and get 390.